this is section 7.5, number 4 from WebWork. And this is the surface area, or the area of a surface of revolution. And you're asked to find the area of a surface obtained by rotating the curve x equals 2e to the 2y from y equals 0 to y equals 4 about the y-axis. It's not terribly important that we sketch this curve, but we do have these formulas. The formula for the surface area when we're revolving a surface about the x-axis or about the y-axis, and either in terms of x or in terms of y for both of them. Oh, this should be in terms of y. Oops. There we go. So 1 in terms of y, and 1 in terms of x, 1 in terms of y, and 1 in terms of x. So we should figure out which one it is we're using here. Here, our function is an f of y equals 2 e to the 2y. And we're going from y equals 0 to 4 about the y-axis. So we're given a function in terms of y, and we're revolving about the y-axis. So we should probably use this one right here. So the surface area is the integral from y equals 0 to 4 of 2 pi, the function 2e to the 2y times the square root of 1 plus whatever the derivative of that function is squared dy. So that's just plugging to this formula right here. The only thing I still need is the derivative. Let's figure out what f prime of y is. That'd be 2e to the 2y times the derivative of 2y, which is 2, or 4e to the 2y. So that would be a 4e to the 2y. Now, this integral is doable. It's not impossible to be done. This integral is a pretty challenging one, though. You could do a u substitution, and maybe I'll do that in a second beneath that line. You could do a u substitution to figure this out, but the important part of this one is just being able to set up, kind of be able to plug into this integral. And at this point, we're not really testing these very challenging techniques of integration. We're more testing your ability to plug in. So I could use my calculator to tell me the answer to this, and it wouldn't be too bad. So what I've done is, in my calculator, I plugged in this function, 2 pi, I put it in terms of x instead of y, but 2 pi e to the 2x times the square root of 1 plus 4e to the 2x quantity squared, all under that, all squared. So I'm going to graph this function, and let me graph this function real fast. It'll look something like that. And then what I'm going to do is I'm going to calculate this function. So I'm going to do, in my TI-84 plus, or TI-83, I'm going to do second trace, or calculate. And I'm going to calculate, in my case, the definite integral, which is 7. So I could scroll down here, just press 7. And I want to see what happens when I go from the lower limit of 0, I'll press enter, to the upper limit of 4. I'll press enter. And the calculator will think for a little bit there, and it'll decide to give me an answer. Oh, it's thinking pretty hard here. Oh wow, it's a pretty big answer. So let's see what this is. This surface area is about 111,666,151. Okay, so that's probably not a super satisfying answer, but this is a big surface area. Excuse me, I had to sneeze. Okay, so that's a fine answer, and if you want to do that to find your answer in WebWork, that's fine. Now, if you really want to try to figure out how to solve this integral by hand, there are a couple of ways. So one way you could do it would be to do a u substitution here, and you would let this thing right here be your u. So you would let u be 4e to the 2y, and then du would be the derivative of that, which would be 8e to the 2y dy. And then you would rewrite this integral. This square root would be 1 plus u squared. You'd want it in terms of du. Your du has an 8 to dy, or 8e to the 2y dy. So you have the dy, you have e to the 2y, and you have 4. You need another 2 in there. So you need 2 times 2 times 2. So you'd multiply by 2 and divide by 2, and you'd get something that looks like 1/2. You'd also take that pi out, so maybe I'll just make that pi over 2, and you'd have something that looks like that. The other thing you would need is you'd need to figure out your limits of integration. If u is e to the 4 times e to the 2y, if I plug in a 0, that would be 4 times e to the 0, which would just be 4. If I plug in a 4 into this, I get 4 e to the 8th. Now this integral itself is not a very easy one. You could use trig substitution, or you could use, like, say, table of integrals number 21 to get this. And what you would eventually end up getting would be pi over 2. If you use number 21 in the table of integrals, it'd be u over 2 times the square root of 1 plus u squared plus 1/2 natural log of u plus the square root of 1 plus u squared. And you'd evaluate all of that from 4 to 4e to the 8th. Now, this answer is not a very nice answer, and that's not really what you're being tested in this problem. Plugging into your calculator and getting an answer, that's fine for this one.